Detail of action potential generation. So now we are going to move on with our material to something new and exciting. All right, so remember again, an action potential is like a nervous impulse. And here we're going to look at exactly what happens to move this action potential across the sarcolemma. So we're going to talk about polarization and voltage, right? So just picture ions or electrical charges, and depending on where there's more or less, there's going to be a shift in the charge. So the action potential is caused by the changes in those charges. And it happens in three ways. One is generation of end plate potential, two is depolarization, and three is repolarization. So let's go look at that. What is end plate potential? It is the acetylcholine being released from the motor neuron and binding to the receptors. This causes the chemically gated ion channels to open and sodium diffuses across. The potassium also diffuses outward, but it's not enough to be significant. And we go back to the sodium on the interior, meaning creating a more positive charge on the inside. Results in depolarization event called the end plate potential, right? The potential now exists. Notice the highlighted material. Please make a note for your exam. So what's happening here? This is a nice little picture of it, and I'm going to show you what we just talked about. Again, it's happening here. So calcium is what initiates the acetylcholine to exocytose out into this area. And then the receptors are down here. They're going to receive that. And here's where the depolarization happens, okay? And this is the area that we're talking about when we look at the action potential propagating. All right, so depolarization is the propagation of the action potential, meaning it's moving down. So the end plate potential causes enough of a charge to reach a critical level. This is the threshold level, and it's all or nothing. So if you reach that level, it'll fire. Again, we are talking about sodium triggering that and moving across the sarcolemma. Okay. So here's the picture of it now. So now let's look at it here. So this was what we pointed out before. Here is a picture of the sodium channels opening, right? These are the sodium ions coming in, influx in. And what happens in here? Is it more negative or more positive on the inside now? Well, if I'm saying a lot of sodium, right, it's going to be a lot more positive, right? A lot less negative, a lot more positive. So repolarization is the return to the resting conditions, the point which existed before the action potential. The sodium voltage gated channels are going to close, the potassium ones will open. So there's a potassium efflux out of the cell back to its original resting membrane voltage, which means it's returning, repolarizing to its original state. There is a refractory period where there's no stimulation possible, and this is just a latent period where nothing can happen. And this whole process of restoring the original conditions is called the sodium-potassium pump, because it's the pumping of sodium and potassium that allows us to have this, this change and restoration. Here is the event in illustration. So we did stage 1, stage 2, now we have the repolarization, and here it is. We're closed here, so these can no longer come in, and we're open here, so some of these can go out, and the resting membrane potential is restored. Now looking at here, we see the voltage, right, and the time. So what happens first is we have that moment where the sodium channels open, causing depolarization, right? We become more and more positively charged. Then that closes and potassium channels open, we become more negatively charged, right? Going back to our original state. And here's our end state here. I could draw on the critical threshold. Would be like at, I think, -75. I have to check that. So just ignore that. I'll come back to it later. Okay, new kind of concept here, excitation, contraction. You have a video on it, so either watch the video before continuing or watch it after this section to be really solid in the material. So this is going to be what basically causes all the myofilament contractions. Again, it's about propagation or movement of the action potential into the muscle cells.